let's keep on going. And here, I'm not gonna even explain that already because it's saying consider only acetone. Now, or this. That's why. I don't think it's very clear this, but because this is CH3C2, I'll tell you what is the acetone. The acetone, you're going to have one CH3 group on this side, right? And then the other one, the carbon with the ketone group, which is a double bond in the middle. And on the other side, you have this oxygen is to the carbon here, okay? That's why. And then on the sides is the carbons with the H. Now, do you need to know? No, well, you didn't know. You didn't need to know that there was a double bond here, but I'm gonna give it to you. Um, so we have here, uh, how many carbon? 3 by 4 is 12 plus 6 plus 6 will be 12 plus 12, 24, right? 12 plus 12, 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 is going to be 20. We need two more. Where can we place them on the oxygen? We need four more. 1, 2, 3, 4. So we should have the 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 by 2, 20 because it's 10 pairs and 4, 24. And we don't even need to do it as if you already like watch the videos with the class, you know, this is zero already, the formal charges. And let's check the octet. I know there's an octet too. I almost forgot. Duet, duet. 1, 2, 3, 4. Then you have oxygen 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We have all the octet complete. Formal charge. Carbon, you know it already with 4 bonds, 0 lone pair is 0. Hydrogen, you know it already. And this one, if you remember, the formal charge of the double bond of the oxygen is with the 2 lone pairs is going to be 0. So we have all the formal charge zeros. Geometry. Let's study the central atom. What is the geometry for the geometry and the shape for the carbon 1? Carbon 1 will have 1, 2, 3, and 4 domain. Remember what we take into account the second carbon. So it has 4 domain, tetra, tetra. Well, all of them are atoms. Doesn't matter if they're carbon and hydrogen. Now here, this carbon, 1, 2, and 3 domains. So what is it? The carbon 2 is trigonal planar and trigonal planar because all of them are atoms. Doesn't matter if it's a double, you don't count them for the geometry and molecular shape. And here we got carbon 3 is another tetra. Tetra, tetra, tet, tet. Okay? Isomer, no, because we're only considering the acetone. There could be an aldehyde in which the double bond comes on this oxygen with the double bond is on this carbon, or this one is the same, the ones on the extreme. That would be, then that would you would have it, but they're only telling you to consider one of the structural isomers. So you got C, a tetra, my H over here, my other C, but remember this is trigonal, so you got, hold on, I think, oxy, you had to see my pictures when I was studying. Excellent. Okay. And then let's think about, yeah, that would be the other hydrogen. One over here and one over here. And there you go. One over here and one over here. My question is it going to be polar, yes or no? Yes, of course. What is the direction? here. And the net is going to be down. Polar. Okay, now let's do the next one. C. Oh, I have to do it smaller because there's isomers there. C2 H1 2 3 4 3H. Now where do we put the oxygen? Hydrogen has to be terminal. Now we know we have to put the oxygen as an alcohol, and that's ethyl alcohol or ethanol. Okay? So you got hydrogen, 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 and hydrogen. Now, this is how I know, and that's why I'm drawing that before doing the electron, the skeleton. What happens if I change, what can I do here to find a structure or isomer? Changing the O, because that's the only one that is different from the rest. What if I change the O again to the middle? Okay? And we leave this hydrogen where it is. So here it is. Anyway, if this goes to this side, it's the same. Up and down the same. The only way is putting the oxygen in between these atoms. Okay? So here you got your two isomers. Yes, two. Now, electrons. 8, 2 carbons, plus 6 hydrogen, plus 6 is going to be 12, it's going to be 20. Okay? So we got, let's study the first one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, and 8. By 2, 16, 17, 18, 19, 20. How do I know? Because it's the oxygen. One of the terminal atoms is electronegative. Here, we have to put it here too. Okay? So we got our Lewis structure. What is the formal charge of this oxygen? Let me write it there and then I erase it. It's going to be the formal charge of the carbon with 4 bonds, you know it. Of the hydrogen, you know it is 0, 0. The formal charge of oxygen would be equal to um, 6 minus 2 bonds plus 1, 2, 4 unshare is going to be 0. Okay, and the same with the other one, 2 bonds and 2 unshare. So it's going to be 0. Perfect Lewis structure. Beautiful. Okay, beautiful. Let's go with geometry and shape. What is the geometry? Carbon 1. Remember, those are the central atom. Tetra, tetra, right? Tet, tet. What is on carbon 2? What do we have? Again, 1, 2, 3, 4. Tet, tet. Okay. And the same here. So we got the first isomer would be H, C, OH. On when you studied advanced chemistry and organic, you don't put the hydrogens in the terminals. You don't just leave the line. Okay, so this is going back. So is it polar? Yes. What direction here? Let's go ahead and look at the other one. You have the carbon, oxygen. We put it up here like this, and it's gonna be one hydrogen, could be up, one as long. We need to find out the way they could accommodate themselves. Don't put them all cluster, like, yeah, cluster is the word. So you got the hydrogen up here, and you got one over here, and the other one back. You see? Now this, Remember, they're going to try to find a position in which they're going to be more apart from each other to minimize the repulsion. Now here, is it polar? Yes, because it's going this way and this way. So the resulting dipole would be this, the net dipole, net mu. Let's go with this one. CO2, I've done it 100 times. I'm not going to do it because I did it. CO2, 1, 2, 3, 4. And we have 4 plus 12, 16. 1, 1, 2, 3, 4, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's the best Lewis structure. 0, 0, and 0. Linear. And linear. And linear isomers, no. Polar, no. Non-polar. Why? Because when we draw our structure, right, what is the most electronegative element? This side and this side. What happened with them? They cancel out because the magnitude is identical. So the net dipole is equal to 0. And 3, in class exercise, we did it. I'm sure I did it. Let's look at this one. PB, BR2, 3. We got rid of the isomers because I think the last one doesn't have either. Yeah. So PBBR3. So you got P, the central atom, of course, and then you got 1, 2, and 3 BRs. Let's count the total valence. It's going to be 5 plus 3 times 7, which is 21. So it's going to be 26. And this is going to be, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't know what I'm counting. We need to get to 26. 1, 2, 3 is minus 6 is 20. So we have, yeah, at 1:34 a.m. I don't know what I'm even counting. I don't know what I'm doing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And here 14, 15. So we got 1, 2, 3, 4, 5, 6, and 6 for each one. 18 plus 6, 24, 25, and 26. By the way, this looks so horrible. Traumatize me. Okay. So, formal charge. Formal charge of Br. This is not bar, Br. Okay, it's gonna be bromine, formal charge. 7 minus 1, 2, 3, 4, 5, 6, and 1 bond. 1 bond plus 6 is gonna be 0. So the 3 bromines are the same, right? It's 0, 0, and 0. How about the phosphor? Phosphor would be 5 minus 3 bonds plus 2 on share, 0. Oh, perfect Lewis structure. 0, all of them. At least that was easy on this lab manual. Okay, let's go for the next one. Geometry. How many domain? 1, 2. Don't forget the lone pair on the phosphor, but it has to be on the phosphor. 3 and 4. 1, 2, 3, 4. So it's going to be electron geometry, tetra. What is going to be the shape? The shape is going to be trigonal pyramid. Pyram. Okay. What was that question? This question on this column, I forgot. Isomers. No. No, there's no way. Okay, so now let's do, is it polar, yes or no? Yes, because you have four domains and one of them is lone pair. So you have one different. So it's polar. Okay? So it's gonna be P, the lone pairs here, one of the bromines here, the other one's up front, and the other one is on the back. Okay? So that means that one goes on this direction, one goes on this direction, one on the other one, so the resultant goes down. So it's gonna be the net dipole, the vectors. And finally, the last one would be CS SCl2, sulfur dichloride. And it's gonna be 6 plus twice 7 is equal to 20. And let's draw it C, Cl, Cl. So 1, 2, 3, 4. Then we put the lone pair 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You can put it up, or, and down, or two up. Because when we represent the 3D, I like to, well, basically the rules. Some rules, some literature doesn't mind. They put like, for example, like this and the lone pairs here. I like it on the same plane. I say I like it. That's the way I I learn it. Oh, that's the way I know it. Period. So here what you have one, two, three, four domains. If you have four domains, two are atoms and two lone pairs, it's gonna be what? It's gonna be like the water. It's gonna be tetra bent. Remember the water was the same? And if you wanna just remember the water a little bit better, usually they put the first two here. Usually you put four. And then if you need more, you put on bulk. Usually you put them together. Here it is. So isomers, no, right? And then let's do polar. Yes, it is. You have four domains and different. So it's gonna be S on this side, one chlorine, on the other one, the other chlorine. And the directions are here of the polarity are one. Okay, going down. So that's it for this one. And I said, I saw my okay. And we're done.